Hello everyone, today we will be doing the Unit 4 review. I'll try to keep it as quick as possible. It's not a very long unit, but it does, have a lot of skills that you got to make sure that you know. So in this top section, it just says simplify. You'll see that there are problems that are like this one where it has a minus versus a multiplication. Keep in mind that if it is a subtraction or addition type problem, you are just going to be combining like terms. So for example, this one, you're going to have your 3 plus I. Uh, you will be subtracting 7 and then subtracting a 6i. Oops, sorry about that. Give me a second. Sometimes it does that. Okay. 6i. And then combining your like terms. So you have that 3 minus 7 gives you negative 4. I minus 6i gives you negative 5i. And then that's your answer. That's the simplified version. Same thing with the addition here. You would just be adding everything. So really you can just drop the parentheses. You have negative 4 plus a 5. You have a negative 9i plus a negative 7i. That type of deal. In the ones that are multiplication, similar to example 2, but I'm going to do example 5 just because I think it's a little bit harder. Make sure that you are, in fact, going ahead and simplifying first. I just think if you try to FOIL right into this, it gets a little confusing. So if you do the square root of negative 9, that's going to be 3i minus 2. And then over here, this is going to become 2i plus 1. At that point, you can then go ahead and FOIL. First, outside, inside, last. That's going to give you a 6i squared. Don't forget to square the I times I, plus 3i minus 4i, and then minus 2. Combining your like terms, the 3i minus 4i gives you a negative I minus 2. As far as the 6i squared, please remember that I squared equals negative 1. So what you really have here is a 6 times negative 1, which we know can be then written as a, wait a second, negative 6. Then you can go ahead and combine the negative 6 with the negative 2, get negative 8 minus I, and then you're done. So that'd be very similar to what you do in example 2. Example 4 is just looking for you to simplify. So this square root, make sure you're considering it as a 5i, and then you'll multiply it by 3 after. The 4 can't really do anything. You can just kind of tag him along. All right, so that's kind of all you need to know for the simplifying. Additive inverse shouldn't be too complicated. I think most people did fine on this. It's just saying the opposite of everything. So that becomes a 2, that becomes a plus. You're pretty much done there. I do remind you that the I should always come second. So if you simplify this, you'll get that 4 and the 3. So that's going to become 2i square root of 3 plus 9. But please remember that real numbers always get written first. So your 9 should be coming first. I might not take off points for that on the test, but technicality, that should be done. Solving, we did kind of talk about this in class. A reminder that if a equals 1, you can go right into your factored form. What numbers multiply to 36 but add to 13? So hopefully you would say 9 and 4, positive 9, positive 4, done. Stop there. Don't try to solve. That's your answer. 15 is the difference of perfect squares. If you see a difference of perfect squares, make sure you're doing a minus and a plus version. This is really saying 4 squared, so you're going to have a 4 there and a 4 there. One's where it's the AC method, so this is going to be your AC method. Make sure you account for what is A times C. That gives me 10. What factors of 10 add to 7? So that's going to give you 5x plus 2x. 5x plus 2x gives you 7. 5 times 2 gives you 10. Then just bring down the 10x squared. Go ahead and get this out of my way for a second. 10x squared plus 1. Combine your like terms. Or sorry, don't combine your like terms. Sorry, backtrack. You do want to then group. Again, if I combine it like terms, it'd get me back to the original. So group here and pull out your GCF. So I'm going to go ahead and pull out a 5x. That's going to leave me with a 2x plus 1. Over here, they don't really have anything in common, so I'm just going to pull out a 1. And then your final factored form is anything on the outside. So 5x plus 1. And then anything on the inside, which was the 2x plus 1. It should be a matching term here, and that is how we know that it should be going in one of the groupings. That's it then. And then the last one here, I'll give you a hint, is going to be your GCF. As far as the next page goes, it says solving quadratics. You will have a mixture of different problems here, so kind of getting used to kind of solving them in all different ways. The quadratic formula will work on everything in this section. So if, for some reason you look at this and you say, I have no idea how to solve this, just quadratic formula it. If you can think of another way, for example, this one, I would probably bring the 16 over and then just square root it. Remember, whenever you square root a variable, you get that plus or minus, and then square root of 16 gives you 4, so it'd be done. So it's very short to do it this way, but the quadratic formula would work, assuming that you said that a equals 1, b equals 0, and c equals negative 16, then the quadratic formula will work. The AC method, which I talked about on the front, some of these might work for the AC method, but if you try it, let's say, 22, and you're thinking what factors multiply to 22 but add to negative 3, if you spend, more than 10 seconds thinking about it and you can't think of anything, honestly, just switch to the quadratic formula, and you will be fine. I will walk through one example of the quadratic formula, and then that will be the end of this video. So I'll do it with this one since these are some bigger numbers. You could do the quadratic formula for this one, but I'm going to go with the bigger numbers here. So looking at this, I'm actually going to zoom in so a little bit easier to see. Okay, so I'm going to have, my formula is the opposite of b plus or minus the square root of b squared minus 4ac over 2a. So the opposite of b, that's going to give me 3. Please don't forget the plus or minus. There's been a couple people that have been forgetting it. B squared, keep in mind that will be a positive 9 because negative 3 times negative 3 gives you positive 9. Minus 4 times a times negative 11 all over 2 times a, which should give me 4. Now here's why I offer some really big caution. When you are multiplying this term right here, the term that I just circled, keep in mind, I'm going to go ahead and put the 9 in there. You have a negative 4 times 2, that gives me negative 8. Negative 8 times negative 11 gives me positive 88. So be careful with that negative. It should give you positive 88 over 4. Keep simplifying, plus or minus. This will be the square root of 97 over 4. Please make sure you then check to see if this right here can reduce to anything. Can it become, square root of square root? If not, then this will be your answer. But if it can break down, like let's say you got the square root of 20, then you should be considering breaking it down into the square root of 4, square root of 5, to root 5, and taking it from there. But in this case, square root of 97 doesn't become anything, so that would be your final answer. So if you double check your square root, it can't go anywhere, then just stop. Other than that, again, some of these different examples, this is going to be your GCF. This one, you could say what things multiply to 10 but add to negative 3. So that's going to be a positive 5 and a negative 2. And then since this one does have that equal sign there, you can actually tell me what x will equal for all of these. This one up here was an x equals. I just forgot to include that. This one, same idea as up here. This one, you could try the AC method, but we talked about this in class. It's not going anywhere. So you are going to want to do, the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Scrolling down, I think there's 2 more down below. Oh, and discriminants. This one, again, you could try the AC method, but anytime there's some big numbers there, I usually just go with the AC method and see how that works out. Please make sure you take your time with the AC method. I will tell you, I don't have the answer key in front of me, but if you go through and solve one of these and you get something, again, totally unrelated, okay, unrelated. Let's say you solve one of these and you get 4 plus or minus, 5 over 6. Okay, let's just say that maybe that was your answer. Make sure you do account for the 4 plus 5 over 6 and 4 minus 5 over 6 and actually get those fractions. Don't just leave your answer like that, no good. but actually get your simplified versions. So do not leave that as your answer. Make sure you actually break down to them plus and minus, assuming that the square roots go away. So the example up here, that 97 did not go away, so just leave it like that. But if the square root goes away, go ahead and simplify, and that should also help you a little bit with 24. Very last thing to talk about is discriminants. Again, that's really just saying if I look at the formula and I say, what's under the square root? B squared minus 4ac. Okay, I want to see what's under the square root. Is it positive or is it negative? So if I come over here, b squared is going to give me 25 minus 4ac. That's 25 minus 24 gives me 1. Now, the discriminant, as far as what is the discriminant goes, is just 1. No square root, nothing fancy, just 1. As far as what type of solution and how many of them you get, think of it like it's under a square root and say, oh, well, the square root of 1 will give me a real number, so I'm going to get 2 real roots. If I get something that's negative, let's say I tried this one over here, that's going to give me 16 minus 4ac. That gives me 16 minus 36. That gives me a negative 20. Well then, okay, that's my discriminant. That's my answer. Leave it like that. But then think about what if it was under square root? Well, if it's a negative under square root, you're going to get an I. Therefore, you're going to get 2 imaginary roots. And that's about it. 20, you should get 0 as your answer, which means you're still technically getting real roots. You're just going to get one of them. So 1 real root for that one. Other than that, again, kind of a quick overview of everything. Checking out the packet. Again, the answer key is posted online. So if you missed anything or missed any of the answers, check out the answer key. I tried to give it as much details as possible. And good luck on the test.